Hello, I'm Pushkar, Master Teacher in Chemistry at Vedantu, and I'm discussing KVPY 2018 SX Part 1 Chemistry paper. Here is a question which belongs to surface chemistry, and in surface chemistry it belongs to the topic Langmuir adsorption isotherm. So before we answer this, let us understand what is Langmuir adsorption isotherm. According to this adsorption isotherm, if we have a vessel, closed vessel, and this closed vessel, if we have a surface, and this catalytic surface is having some active sites. Sorry, suppose some active sites are there. So these active sites are basically free valency states or unbalanced valencies, free valencies, which is responsible for catalytic activities. So the surface always have some numbers per unit areas of these active sites. They are responsible for catalytic activities, and on these sites some atoms will be adsorbed. Few atoms will be adsorbed. Let's use a different color combination to show it the adsorption process. Let us suppose that these molecules are adsorbed, and these are certain other molecules which are there, and they are a process of getting adsorbed here. They are randomly moving, and when that is absorbed for some time, it is converted into product, and it may change into what? Suppose the product is of black color. Suppose this is the product. According to Langmuir adsorption isotherm, let's come back to the original color. According to Langmuir adsorption isotherm, first of all, first assumption is that active sites adsorb molecules. As we can see, a lot of molecules are getting adsorbed here. Second point, adsorption is dynamic. Process, which means that two processes are taking place. Adsorption is in equilibrium with desorption. So the molecules which are sitting here will not sit for permanently. After some time, they'll be converted into product, and they'll go back into the solution, into this vessel. So the process is taking place. Adsorption, desorption, both are taking place hand in hand. And the rate of adsorption at equilibrium, rate of adsorption is equals to rate of desorption. Some kind of equilibrium will be attained. Soon a steady state will be attained. Rate of adsorption will be rate of desorption. So based on these thoughts, we can develop the Langmuir adsorption isotherm, which tells us that x by m is equals to AP plus 1 plus BP. Something like this, where A and B are the constants. We can easily show that this will be the expression for adsorption. So let us find out what could be our correct options. The free gas and the adsorbed gas are in dynamic equilibrium. Of course, that's a correct statement. Both things are happening hand in hand. All adsorption sites are equivalent. Of course, that's also correct. The initially adsorbed layer can act as a substrate for further adsorption. No, because this will lead to multi-layer adsorption. And in Langmuir adsorption isotherm, we consider only the single layer adsorption. So the initially adsorbed layer can act as a substrate for further adsorption. That's not possible. That is a That is a wrong statement because adsorption is dynamic in nature and active sites are adsorbed molecule and adsorption is monolayered. Adsorption is monolayered. That is the assumption of Langmuir. Okay, so this thing is a factual thing, that's a part of the theory. So keeping in mind, the third option is wrong option. And the fourth option is the ability for molecule to get adsorbed at a given site is independent of the occupation of neighboring sites. Of course, it's right, because no way the molecules which are getting adsorbed on an active site is getting affected by the presence of other adsorb atoms. It is independent. So it will take its own decision and get here and get adsorbed. So option 4 is also a correct option. So choosing these correct options, I think that our answer is B, only 1 to n. 4 is correct option. So we'll go with this option B. That's a slightly difficult question, more factual question. Must read through it very carefully. Thanks for watching. Stay tuned for discussions of many such questions.